law of cosines because, look at this problem right here. We don't have a pair of anything. We don't have the angle and the side that's across from it. So here we don't have a pair. We don't have both x and x, or y and y, or z and z. So we cannot use the law of sines. But I do want you to notice how there are three pieces of information. There's always got to be three. If we don't have that much, that's not enough information to solve it. We have two sides and the angle between them. That's going to be the law of cosines. So we're going to have to, this time, find side y first. Now you'll notice there's no x, y, or z in here, and I actually prefer it that way because if this triangle had been A, B, C, and we need to find side B, that gets mixed up with this one is helping us find side A. So I like to do it this way. You'll notice we still can do everything. So let me show you this time. We're going to find side y first. And then here we have A and then the other two sides. So here's y. We're going to have the other two sides of x and z. So it's going to be x squared plus z squared, and then minus 2 times these same two sides. So minus 2 times x times z, and then times cosine of this corresponding angle. So this one's going to be cosine y. So we're going to have y squared equals 32 squared plus 35 squared minus 2 times 32 times 35 times cosine 49 degrees. So here we got y squared equals 779. Now we want to know y, so we're going to do the square root of both sides. When you get the hang of these things, I will tell you, a lot of people do these, and then they stop here and think, oh hey, that's 779. And then they come back up here, and then they realize it's not possible, and I was going to say not logical either, for you to have a triangle with sides of 35, 32, and almost 800. And so then that's usually the reminder that people need to say, oh yeah, I just have to do the square root of both sides. So now, because I have the angle and the side that's across from it, I have a pair. So now I have enough information to finish this problem using the law of sines. So I have sine of x over x equals sine of y over y. I'm going to multiply both sides by 32. So remember, I'm not looking for sine of x, I'm looking for angle x. I want to know the angle, I use the inverse trig function for that. Now we're going to do the law of cosines, solving for the angle. What you see up here is the equation. It's really equal to cosine of A. That means at the end we're going to do the inverse cosine to find the answer. And if you also look, we're going to find angle A. So your numerator has the other two sides. Sides B and C are both positive, but A is negative. And then you'll notice in the denominator, it's 2, and then B and C, the other sides. So notice where all the patterns are. If you're looking for angle A, it's going to be right here, and then side A is right here. And then everything else is the other two sides. The reason we're using the law of cosines is because we do not have a pair. Again, we need an angle and the side across from it to use the law of sines. And we only have the three sides. So I'm going to start with angle Z equals, and then we need the other two sides. So x squared plus y squared, and then minus z squared over 2xy. So look at how I have this typed in. Can you see it? Hopefully. Put it all in one fraction. You guys are so lucky with all these fancy calculators now. In the past, we always had to be careful, make sure the parentheses were all in the right place, make sure you really paid attention to the order of operations. If you just put it in here like this simply, you will be fine. So I need to do the inverse trig function. When you find the angle, you're going to do the inverse trig function. This time we're going to do inverse cosine. Okay, so here I have a pair. I have angle Z and side Z. That's enough information to use the law of sines to find the rest. Now this is really your choice. Lots of people think, hey, the law of sines is more simple, I'm going to do that. And a lot of people think, hey, well, I'm doing the law of cosines, I'm going to stick with the law of cosines. I don't need to be switching back and forth. It really is a personal choice. You do what you want to do. I am going to do the law of cosines. I have it here. I'm going to give you another example. I'm going to show you that it works that way. Generally, I guess I've been both of those people at some point in my life. It's really a personal preference. I could do the law of sines this time. I could do the law of cosines again. Honestly, I've got two angles. I'm going to add them up and subtract from 180. But you could do it to check if you would like.